All right, last two examples then. It's the process for determining equations from graphs. So here are the steps. Step one is identify the roots. So identify the roots. So our roots would be at +2 and at -4, it looks like. Step two, determine the degree of each root. I'm going to talk about that in a little bit more detail in a second. Degree of each root. And step three, find a known point. And in brackets, not an x-intercept on graph. And step four, find coefficient. So there is the 4 steps simplified, and we'll talk about each one. All right, so I already identified the two roots. They're at +2 and -4. So there's only two roots. So my equation is going to look like this. There's a coefficient out front. I don't know what it is, so it's going to be an A. One of my roots is at -4. When I put it into my graph, it's going to be +4. My other root's at +2, so it'll be at x -2 then. So that's step one. Step two is to determine the degree of the root. So when you look at -4 here in the little box, oops, I want to zoom in. There we go. From what you can tell, in that blurry red thing, it looks like a line. Okay, it crosses that little segment that we're looking at. It looks linear, so we're going to have it as a 1, degree 1. At the -2, or sorry, at the +2 root, if we zoom in, I didn't want to do that. If we zoom in on it, and you look at the red, a little zoomed in a little too far, but it looks like a parabola or curve, so that means the degree is 2. So that would mean that, I'm just rewriting it, this is what our function is going to look like with the degrees added in. So that's step number 2. Step number 3 is to find a point on the curve, or on the graph. So I'm looking at this graph, and you can pick pretty much any point except the x-intercepts. So you could pick a point here, a point here, a point here. The whole key is to pick something that looks fairly easy to read. So this one, to me, looks almost like it's at +5 and at 4. So I'm going to try using that point. It doesn't matter really which one you pick. It's going to be pretty close, and I'm looking at process anyway. So I'm going to say if the function, when x is 4, I know that the y value is 5. I'm now going to do a substitution to solve for a. So I know that f of x is equal to 5. That's the y value. A unknown. My x value is going to be 4. So 4 plus 4, 4 minus 2 squared. So I'm going to have 5 equals a, and I'm going to do a lot of steps here. That's 8. 4 take away 2 is 2, and 2 squared is 4. So 5 equals a multiplied by 4 times 8 is 32. Divide both sides by 32. And we find that our a value is 5 over 32. You report it as a decimal, but it doesn't matter. I'm just going to leave it as a fraction because I don't have to get a calculator out. And this equation will fairly closely model the graph that we have here. Is it going to be exact? Definitely not, but it's going to be pretty close. So if I go to my calculator, graphing calculator, and just to prove to you that it's actually going to work, I'll enter it in here. So bracket 5 divided by 32, bracket x plus 4, bracket x minus 2 squared. If I hit graph, see what shape comes out of it. Oh, I gotta probably change my window, of course. And should have went back to basics. Try that one more time. So I'll just scroll up here so we can compare that side by side just so you can see. If you look at it, it's pretty darn close. It's not perfect. All right. It looks like 1, 2, 3, 4. The max goes up a little bit higher than what mine does, but for the most part, it's going to be close enough for anything we're doing in this course. All right. One last one before I let you go and try some of the homework. So f of x equals some coefficient, and identify your roots. So I've got one at -4, so it'll be x plus 4. I got one at -2, so it'll be x plus 2. And I have one at +3, which will be x minus 3. Next, we identify the degree of the root at each place. Here it looks like it slides through like an S curve. So that particular one will be cubed. This one passes through. To me it looks like a line, looks linear, because you're only looking at the very little segment passing through the x-axis. And over here looks parabolic, so it will be squared. So your interim function is exactly what we have written there. And I am just rewriting it underneath like that. Next, we need to find a point. So, again, this is the tricky part because you're looking for something that's pretty close. And like I said, I'm looking for the process. So if it's not the exact point, I'm still going to be quite happy. So I'm going to say -1, -3 looks fairly close. So if f of -1 equals -3, and quite honest, if you can find a y-intercept, that one's the best. But there's no y-intercept on this graph. It goes off our screen, so we're going to have to make do with another point. But again, if you can find the y-intercept, that's the best one to choose. So -3 equals a. -1 plus 4 is 3. 3 cubed is 27. -1 plus 2 is 1. And that's going to be -4 squared, which would be +16. Now, I'm going to have to actually use a calculator. 27 times 16, 432. So A will equal -3 over 432. Again, this is approximation. It's not going to be exact, but it's going to be pretty darn close if you take your time and find the correct points. So x plus 4 cubed, x plus 2, and x minus 3 squared. So there you go. That's how you determine the equation of an unknown polynomial. Here's the homework. So you're going to be going through and you're going to be identifying degree, roots, and so on and so forth. So following through the notes, and if you have any questions, please let me know. Thanks.